Welcome to the HBM Test and Measurement FAQ video series. Hi, I'm Bart Morick, HBM Applications Engineer, and in this video I'm going to provide a short presentation on stress testing printed circuit boards using strain gauges and a data acquisition system. Stress testing printed circuit boards, or PCBs, is becoming more and more prevalent in today's mechanical design. In order to plan for your testing, you will need strain gauges, a data acquisition system, and software to control. Then you need to decide where to place the gauges, install them, connect to your data acquisition system, make your measurements, and then analyze your results. Electronics are all around us, and that means PCBs are there as well, in ever-shrinking packages. Our need for these devices to be reliable and functioning for every moment of every day means that they have to survive the harshest of environments. Cracks can occur in PCBs or between the PCB and its components. Damage can be built into the PCB during the production process by using the pick-and-place machine. Design engineers need to know where the damage is and where it may come from in order to improve their designs. This video will give you an idea of what the typical PCB sees when the pick-and-place machine is operating. Knowing what stresses the board sees during the manufacturing process will allow engineers to improve their designs and allow manufacturers to know the potential weak spots in their PCBs before they get out into the field. Knowing those weak spots will provide the mechanical engineer with more information to provide a more robust packaging design. HBM has designed a strain gauge of perfect size for PCB testing. In order to work in limited space, the gauge has to be small and provide multiple results from a single point. The RF9 series gauge has a 5 mm diameter and in a stacked rosette configuration in a 0, 45, and 90 degree orientation to enable you to determine the biaxial stress state with unknown principal stress directions in very confined spaces. Our Z70 is a fast-acting superglue that contains a single component and is easy to handle. A great data acquisition system to consider when making strain gauge measurements is our Quantum X MX1615 or MX1616. It offers 16 dedicated channels that are suitable for precise and safe data acquisition of strain gauges in a full bridge, half bridge, and quarter bridge configurations, as well for strain gauge based transducers, potentiometers, resistance thermometers, or normalized voltage. It offers individually configured measuring rates per channel up to 20 kilosamples per second. Connection is quick and easy with the easy to use push-in connectors and provides an internal shunt resistor. We recommend using the Catman software with the Quantum X MX1615 or 16 system when making these types of measurements. The software is easy to use. You can quickly set up your system with a sensor database and perform the math for the rosette calculations. From there you can generate reports or export the data in many different formats. See some of our other videos for more detail in using Catman as your data acquisition software solution. You need to decide where to apply your strain gauges. Each PCB has known hotspots where they're going to see a lot of stress when the components are placed by the pick-and-place machine on the circuit board. To prepare the board, you need to identify these hotspots and decide where you're going to place the gauges. The components in those positions need to be removed and remove the first soldering layer. But do not remove too much of the material from the printed circuit board, as you do not want to weaken the board artificially. Here's a picture that shows a sample of a board with several strain gauges installed in various positions that allows you to get a thorough understanding of what forces your circuit board may see. Apply your gauge using standard strain gauge installation procedures. When deciding on the orientation, define your main direction, the 0 degree direction of the measurement grid, parallel to one of the board borders. Solder wires for connecting the gauge to the amplifier. After the gauges are installed, you can go ahead and prepare to run the test. Connect the strain gauge to the amplifier. Launch the software and configure your channel and create your math channels. Define the sample rate and run your measurement. With Catman, you can visualize the data during the test. Stop the measurement, save your data, and create a report with your results. Thanks for watching, and if you have any questions, please feel free to call, email, or visit our website for the latest product, solutions, and downloads at www.hbm.com.